Okay, just add a comment on the previous video um that um that this equation why is it good is because 11 just stands for the 11 balls, and then 1, 4, 4, 2 are how many like um letters were sent into the box. So this is just M, 1M, 4I, 4S, and 4P. So the shortcut is just like adding factorial on this. Similarly, for 52 cards, distributing 5 to 4 players, it's just the total balls we have is 52. And we know that the first needs 5 cards, second needs 5 cards, third needs 5 cards, fourth needs 5 cards, and there's still 32 cards haven't been distributed yet. So the shortcut is just add factorials on this term. So that's why we like that's why this calculation is easier. It can be easier to remember. Okay, so next let's talk about let's talk about indistinguishable to distinguishable. So indistinguishable is also called identical. An example is that, for example, we have like 10 indistinguishable balls, and we want to distribute it into 8 distinguishable bins. So like indistinguishable is basically means ball and ball are identical to each other. So if I place like say if I have 10 balls, and if I place the first and second ball into bin 1 and place the last and second last into bin 1, that's the same thing because all the balls are identical. So the way we solve this problem is to use the divider. So that's the keyword for this type of problem. So the idea is that you first put 10 balls on the plane, and then to make a separate into 8 bins, we need 7 dividers. So we need 7 dividers to divide this ball in different bins. The idea is, given that I have 10 balls, I can set up the divider in any of the position of these 10 balls. Instance, empty box are allowed. So that this problem can be translated into how many. So like in total, I have 10 balls and 7 dividers. So it's basically from this 10 plus 17 positions, I want to choose 7 positions for divider. So that's how we translate this problem into a simpler problem that we are more familiar with. So that is easy. Let's just 10 plus 7, choose 7, because we're choosing out of 10 identical balls, 7 dividers. We want to choose from these 17 positions, and we want to choose 7 positions that is designated for the divider. And it makes sense because even if the two dividers are not next to each other, that just simply means this bin is empty. Like any 2 dividers determines a bin. So 7 dividers, this would be in 1, in 2, in 3, 4, 5, 6, 7, 8, because we have total 8 bins. So let's just 17 choose 7. So just remember that the 7 comes from 8 minus 1, which is for 8 bins, we only need 7 dividers, divide the space into 8 subspace, or 8 minor spaces. Another typical problem of that is solving an equation. The common solutions will either be for x1 plus x2 plus x3 plus x4 equal to maybe like 10, where they're all positive integers, or they can be either way, non-negative or positive. So say like they're all non-negative integers, so that's basically the same problem as the previous one. We just need 3 dividers to divide the space into 4 space. It seems like 10 is just stands for like 10 ones. So instead of writing 10, we write 1 plus 1 plus 1 plus 1 plus 1. We have 10 ones. It won't, since like each variable is integer. So essentially we're just placing the identical ones into these 4 bins. So the way we do that is 10 plus 3, choose 3. And the 3 comes from 4 minus 1. So only need 3 dividers to divide the space. And then from out of the 13 positions, we want to choose 3 positions, that is for the divider. And I can make the problem a little bit harder. So say I had a condition that x1 should be like greater or equal to 2. So if I have that condition, I just like rewrite the equation into y plus x2 plus x3 plus x4 equal to 8. Y is equal to x1 plus 2. So now I'm changing the original condition. So that's just to clarify, that's the new problem, that I have the condition that x1 has to be greater than 2. So the way to solve that is we change this variable to be y equal to x1 plus 2. So y will have the condition that is greater than or equal to 0. And similar for x2, 3, 4. So we can do the same thing as what we did before. Just 8 identical ones and 3 dividers. And out of these 11 positions, we want to choose 3 positions for the dividers. So that's a solution for this problem. Again, I want to emphasize that there are a lot of types of these problems, and each problem maybe varies a little bit from the previous one. But as long as you understand the fundamental type of problem, you just like, for example, this problem will have one restriction on x1 greater or equal to 2. So you just solve this equation. You just solve this restriction. There might be like other variants, there might be other restrictions. We just solve those specific restriction and translate the problem back into the form that we are familiar with. And that's it for this video.